Good morning, Honorable HOD sir and the faculty members of the Department of Fire and Safety. Today we are here to showing you what implementation we have done regarding our project, which has been assessment of firefighting requirement in textile industry under the supervision of Professor N.K. Jain sir. As we all know, our project divided into chapters so we can easily understood the objective, the problems and eventually their solution. So, with the same chronology as same as followed by others, our project contains 6 chapters, including first of all the introduction, second is literature review, third one is area of study, fourth one is problem formulation, fifth one is methodology, and sixth last one is problem solution. We have made this project by the help of 6 people, including myself, Radhesham Kamde, second is Vaibhav Akhand, third is Rohit Verma, fourth is Mohammad Tabish, fifth is Ronak Jain, and sixth last one is Rohit Verma. In the past few years, in textile industry, many accidents have been reported throughout the world because of minimum activeness regarding fire fighting installation and their maintenance, and therefore we must be use proper codes and procedure described by the government of India and international norms. So first of all, we are going to see the introduction. Modernization is a continuous process and there should be concerned effort to modernize both machinery and manufacturing process regularly. It is general experience that units which maintain the process of modernization systematically could manage to sustain their growth in long run. Modernization is needed to increase production, reduce the cost of production, rationalize labor, reduce maintenance and power cost per unit of production. Indian textile industry largely depend upon the textile manufacturing and export. It plays a major role in the economy of the country. Indian textile industry is also the largest in the country in terms of employment generation. So there are many processes in the textile industry, including spinning, weaving, dyeing, printing, cutting and sewing. So first of all, we are looking at spinning. The formation of yarn from fibers by spinning becomes possible when they have surfaces of cohesiveness. Flexibility permits the fibers to be twisted around one another.
Hello everyone, moving forward to the second chapter, literature review. In this section, some strategies of safety and training in textile industries are as follows. According to Ken, a continuous improvement plan to check act in short PDCA. There are 14 elements which should be implemented for the benefits of the occupational strategies and health management system, which are as follows. Safety policy, safety organization, in-house safety rules and regulations, safety training, personal protective equipments program, inspection program, safety committee, emergency preparedness, control of subcontractors, accident incident investigation, safety health assurance program, safety of promotion, process control management, and job hazards analysis. However, the effectiveness and suitability of the established occupational safety and health management system ought to be evaluated and monitored so that the improvement could be identified. Now we are moving towards Pawan's Kumar method to find out RPN, risk priority number, for all the hazards in the textile industries, and fault tree analysis FEA is over for the hazards with highest RPN, and due to avoid the major hazards occur are chemical, physical, ergonomically and physiologically risk, along with the sub of things which can be create risk are more working hours, improper ventilation. Most of management due to aware of health and safety and other difficulties in that the working people in the textile industries are uneducated and unaware of OHS. This circumstances is very difficult to control the hazards and promote OHS to the worker. The hazards are ranked by the based on the RPN number, the RPN number is calculated by the multiplication of severity, probability and detectability. The main objective of the study is conducted due to the reason measures. First, work surroundings problems such as noise, lighting, humidity, temperature. Second, to find out hazard in the textile and tell the accurate control measure. Third, identify unsafe working condition in the textile industry. Now we are moving towards the conclusion for the whole discussion. The textile sector contains several exposures and risks to workers, ranging from exposure to noise and hazardous substances to manual handling and working with unsafe machinery. As a matter of fact, all the sections described in this paper were the key elements of existing work of safety and training programs of health management system in textile industry. Through the implementation of these elements, the benefits of the safety and training programs health management system could be observed and studied. However, in future needs to improve the safety and training programs in textile industry, especially for spinning industry. This improvement is used to protect the workers from the harmful hazard. Now moving forward to the chapter 3, area of study, processes in a spinning industry. Spinning is the process of conversion of fiber into yarn. There are various processes takes place in spinning such as cotton mixing, combing, carding, drawing, winding. Figure 1 shows the flows diagram of a spinning process. Now I will briefly explain the process, above process one by one. Cotton mixing. As we all know that cotton is the natural fiber and produced from different stations. The properties of cotton such as strength, length, color gets vary, so that in cotton mixing process 4 to 5 lots are mixed to get a specified quality yarn. Now carding. Carding is defined as the reduction of an entangled mass of fibers to a filmy web by working between two closely spaced, relatively moving surfaces clothed with sharp wire points. Carding process includes opening to individual fibers, elimination of impurities and dust, removing of nips, elimination of short fibers, fiber blending, fiber orientation and silver formation. Drawing. Now drawing draw frame. Drawing is a process by which silver are blended, doubled and leveled in short staple spinning. The term is only applied to the process to a drawing frame. Spinning. Spinning is the process where the yarn is produced. The simplex bobbin are fed to these machines where they are drafted, twisted and wound in a small packages known as ring cups, weighing 50 grams each. Processes in weaving area. Weaving is the most popular way to fabric manufacturing. It is primarily done by interlocking two orthogonal sets, warp and weft of yarn in a regular and recurring pattern. Now, further slide will be explained by Vaibhav Khand.
Chapter 4 Problem Formulations. In problem formulation comes hazards in textile industries. A hazard in textile industries are varied and encompasses as many aspects like hazards related to machineries, handling of materials including the chemicals and fire hazards, etc. There are basically 4 types of hazards in an industry, which are physical hazard, electrical hazards, ergonomical hazards and physiological hazards. First is physical hazards. The conventional winding machines poses a hazard of trapping the hands in between the rotating drums. Employing skilled operators on these machines is essential. Automatic winders like the cone winders and spoolers have prevented the hands reaching the vicinity of the rotating machines. Physical hazards are as follows. Light hazards, which causes eye strain and glaring. The remedial measures are proper lighting conditions. Second is lifting heavy weight, which causes musculoskeletal disorder, and the remedial measures are keep your backbone straight while lifting the load. Second is pull the load as close as to the body. Third is lift and carry load with straight arms. Third hazard is noise hazard, and the remedial measures are isolation of the machines and silencer must be kept. Second is inverted drive control noise in a ring frame, and the third is proper maintenance of the machines. Second is electrical hazard. Improper earthing and improper isolation causes electrical shock, moisture, and motor high-speed rotating due to the high voltage causes problem to the machine. Uses of old wire which causes cable melting and heating and poor maintenance are major part of the electrical hazards. Electrical hazards are as follows: improper earthing, and the remedial measures are avoid improper earthing and loose connections. Second is improper isolation which causes electrical shock, and the remedial measures are all circuit is to be enclosed in a proper isolation. Third is moisture, and the remedial measure are moisture to be kept in control. Fourth is motor high speed rotating to the high voltage which causes problem to the machine, and the remedial measure of this hazard is to the circuit breaker must be individual. And the next is uses of old wires by which the current won't be in a flow, and the remedial measure is use of wires as per electrical standards. And the last one is input power cable exceeds more output power which causes melting of the wire. The remedial measures are input wire must be of more power than the output. Third is ergonomical hazards. Posture force, pushing and pulling, repetition, vibration and pressure of the body, and poorly designed work procedure all are the causes of ergonomical hazards in a textile industry. Ergonomical hazards includes continuous work and improper workstations. The hazards are as follows. First is uncomfortable workstation and height which causes pain in the hands and legs. The remedial measure is importance of ergonomics. Second is repetitive strain injuries which causes pain in the wrist, neck, shoulders, neck, knee and ankle, and the remedial measures are proper working procedure. Chemical hazards. Chemical hazards. The processing of textile generally involves dilute acids and alkalis, bleach liquors like chlorine and hydrogen peroxides. Generally, the concentration of the processing liquid doesn't exceed the safe concentration level, but there are slightly chances are available of chemical hazards. Next is fire hazards, which comes also under the category of ergonomical hazards. The inventory where the cotton bales are stocked should be well ventilated so that the hoop iron do not import and generate spark as source of ignition. Use of naked flames for soldering and welding on shaped floor should be under permitted supervision. Third is mechanical friction with the availability of dripping, lubricating oil and loose fibers could initiate the fire. It is also desirable to store in isolation freshly dyed fabrics as they could ignite due to the spontaneous ignition.
Okay.
These were the hazards present in the textile industries. Now comes the chapter number 5, which is methodology. In methodology, we study risk assessment in 5 steps. In first step, we have to identify the hazard. In second step, we have to figure out who might be harmed, in which way he might be harmed. And in third step, the evaluation of the risk and precautions are decided. In fourth step, we record our findings and implement them. And in fifth step, which is the last one, we have to review our assessments and update it if it is necessary. Thank you.
Okay. Finally, in the last segment, we are going to look at final and most important chapter, which is solution domain. Throughout the solution domain, many codes and norms prescribed by the international norms and codes by the central government, including Section 38 of the Factories Act 1948, electric installation and separation of wall, should be imposed to reduce accident and unlawful activities in the premises of the factory. Additional requirement is laid down under IS 1642/1988 are to be followed. First, a minimum distance of 30 meter should be maintained between cotton godown or cotton waste godown and the manufacturing and processing section of the mill. Second, a minimum distance of 50 meter should be maintained between the godowns and manufacturing processes section, except that such distance may be reduced to 6 meter in case of engineering and hardware stores. Third, waste plant should be spaced not less than 50 meter from the mills, working and storage blocks unless separated there from by separating wall. Fourth, godowns for storage of extra hazardous chemical should be located at a minimum distance of 50 meter from all surrounding structure. Fifth, fire pump housing, boiler house, transforming house and electric generator section should be spaced not less than 50 meter from the manufacturing process and storage area. So finally is electrical installation. What kind of precaution we should take and what kind of measures and the norm prescribed by the government we should use here are as follows. So first one is the electrical installation should be accordance with IAS 16461982. Second is all motors should be of the totally enclosed type. Third one is all equipments should be of metal clad construction throughout, dust tight and of adequate capacity. Fourth one is machines having excessive vibration should not have the electric and switchgear mounted thereon. All electrical equipment in gas singeing room should be of the flame roof type. In case of machinery for singeing of yarn by electricity, interlocking arrangement to ensure that heating element cannot be switched on while yarn is stationary in machine should be provided. And the final is similarly for infrared or similar heating devices, interlocking arrangements should be provided to ensure that the heating element can't be switched on while the machine is stationary, but separate arrangement may be made for preheating at the start of the day.